Welcome to the guided video instructions for the Physics in Action Week 3, which involves the circuit construction kit. You can use this video to answer the questions for this week's assignment if you are unable to run the simulation on your computer on your own. I will be working through the simulation as the instructions state, and you should be able to answer all of the questions below based on what you see on screen. All right, so in scenario 1, I'm going to be setting up a circuit that connects a 9-volt battery with a resistor. And I'm going to use my wires, of course, to connect those things in the circuit. All right, whoops. Once I connect this final piece, then my little blue electron should start flowing. And that shows me that current has started flowing throughout the circuit. All right, so I want to check my values by clicking the Show Values button on the green option box on the right side of your screen. And it shows me that I have exactly what I need for the instructions, which is 9-volt battery and a 10-ohm resistor. Now, question number 2 asks, what is the current throughout the circuit? Now, the device or the tool that I'm going to use in order to measure current is going to be the non-contact ammeter. So I'm going to move the crosshairs over the wire, and it's going to give me a reading of 0.90 amps. You should see that as one of your options for question number 2. You can see that if I move this ammeter anywhere else in the circuit over the wire, that it will also read 0.90 amps. Question number 3 is not concerned with current anymore, but it does want to know the voltage across the resistor. So I'm going to select my voltmeter under my tool box, and I'm going to connect to either side of the resistor to figure out the voltage drop. And I can see that it reads 9.00 volts. So the voltage drop across the 10-ohm resistor is going to be 9 volts. And you should see that as one of your options for question number 3. All right, moving forward to scenario number 2, I'm going to reset my simulation here. And I'll get rid of my voltmeter for now. I'll probably need it in a little bit. Scenario 2 has a slightly different setup. I still have my 9-volt battery. I'm going to have my wires, of course. And this time I'm going to be connecting 2 resistors in this circuit. And we'll connect the last 2 pieces here, allow my current to flow. There we go. All right, and if I hit Show Values, we'll see that the default settings leave my battery at 9 volts, which is perfect. That's what we want. And then we have one resistor at 10 ohms, but I'm going to see what happens when I change the resistance of one of the resistors. So instead of having 2 10-ohm resistors, I'm going to increase the resistance on the one on the left and make that 20 ohms instead. Let's double check my values here. Good, and then we again want to measure the current and voltage. But for number 4, the first thing that you have to answer is, are these resistors arranged in series, in parallel, or in both formations? Now you can tell, I'm not going to tell you the answer to this one. This should be something that you recognize from your textbook or your chapter reading for this week. But you should be able to tell by the way that these resistors are placed inside of this circuit if this is series, parallel, or both. So go ahead and select your answer for that now. All right, number 5 wants to know what the current is throughout the circuit. So I'm going to again use my ammeter, move it over the wire, move the crosshairs over the wire, and I'm going to get a reading of 0.30 amps everywhere throughout the circuit, I'm going to get that same reading. So number 5 will be 0.30. Number 6 and 7 are concerned again with the voltage drops across the resistors. So I'm going to return my voltmeter to the screen. And number 6 first wants to know about the 10 ohm resistor. So if I move my pieces to either side here, I can see that the 10 ohm resistor gives a reading of 3.00 volts. So number 6 will be 3 volts. Number 7 wants to know what the resistance is across the 20 ohm resistor. Across the 20 ohm resistor, you get a reading of 6 volts. And so that's the answer to number 7, which is 6 volts. And if you notice, remember that the total voltage coming from the battery was 9 volts. We had 3 volts across the 10, 6 volts across the 20, and that should show you that you give a total reading across the resistors of 9 volts. But individually across each of them, it was 3 and 6 respectively for 10 and 20. All right, scenario number 3. I'm going to reset my screen here and again move my voltmeter for now. This time I'm going to again connect 2 resistors into my circuit with a battery, but this time I'm going to arrange them a little bit differently to change the circuit. You might get a good idea of what type of circuit this is just by the way that these things are being arranged right now. All right, last wire, so it flows the entire way through my circuit. Okay, so I have connected my circuit as required. Now I want to make sure that I have the right values here for scenario number 3. I do have a 9 volt resistor, but I want to change, a 9 volt battery, not a 9 volt resistor. That doesn't make any sense. The resistance of the first resistor, I want to change to 20. And then the second one on the bottom, I want to change this to 5. Okay, and now let me just check my values here. Perfect. Okay, so number 8, again, asks you, are these resistors arranged in series, in parallel, or in both formations? And again, I'm going to ask you to check your selection now. Number 9 wants to know what is the current on the branch with a 20 ohm resistor. So I'm going to select my ammeter, and I want to look at the branch that had the 20 ohm resistor across it, and I'm going to see that I have a current of 0.45 amps. So that'll be the answer to number 9. And then number 10 asks me for the current across the branch of the 5 ohm resistor. And I see that that has an increased current of 1.80 amps. Now, that should make sense because there's more resistance across the 20 ohm branch. So if there's more resistance, then that's going to decrease the amount of current. Remember that current and resistance are going to be inversely proportional to each other. The greater a circuit or a component of a circuit resists the flow of electrons, then the lower that current will be, because current, by definition, is the rate of the flow of electrons. And you can even see on the simulation here that the blue dots are moving a lot slower across the 20 ohm resistor branch than across the 5 ohm resistor branch. And that's because the resistance is decreased in that branch. All right. So now, again, I want to look at the voltage. And it says, what is the difference in the voltage drop across each branch? And so let me check. 20 ohms 9 volts across, 5 ohms, 9 volts across. So in this case, when the circuit is set up in this way, the voltage will be the same across both of the resistors. So in this case, each branch will have a voltage drop of 9 volts, which is the entire voltage of the battery. All right, and then number 12 is a calculation problem. This is one that you will want to do on your own. To calculate the total resistance in the circuit, you will need to recognize what type of circuit this is. The answer to what you put for whatever you put for number 8, and then you'll use the equation for total resistance in a circuit in order to calculate the total resistance in this specific circuit. So I'll give you just a second to work that out, or you can go back to it at the end of this video. Either way will be fine. All right, and finally, I believe, yes, finally, scenario number 4 gets a little bit more complicated. So we have a pretty intricate setup here. We're going to have 2 batteries. We're going to change them to 12-volt batteries. And we have 1, 2, 3, 4, 5, 6 resistors that we are going to connect in a very specific way. All right, there's all my pieces. Now I need to connect all my pieces with wire. I'm not going to have a very symmetrical circuit. I'm not very good at that. I'm going to move it over, make it a little bit prettier for you. Look a little bit like the picture in your instructions. All right, so I connected part of it and I got the electrons flowing through there. I want them to be flowing through all of my resistors, so I need to continue to connect these. Remember, it needs to be a closed circuit. An open circuit will not allow the electrons to flow. I've closed most of it, and this final wire should close. There we go. Now we got electrons flowing through all of my resistors. Okay, so the first question asked, number 13, asks, what is the current through the branch with the 20 ohm resistor? So again, since I'm measuring current, I want to use my ammeter. Oh shoot, I need to change all of my values here. That would have given you all incorrect readings, and I don't want to do that. I'm not trying to mislead anyone here. Okay, so change my voltage. I need 12 volts and 12 volts here as well. 20 ohms. 5 ohms. 5 the whole way across this branch, actually. And then 15 for my final 2. Okay, good. Now let's check. That looks a little bit more like the picture. 20 ohms, 12, 12, 5, and 15. Okay, good. Now I can measure the current through the branch with the 20 ohm resistor now that I actually have a 20 ohm resistor. So I'm going to hover the crosshairs over my wire, and I'm going to get a reading of 1.2 amps. Number 14 and number 15 want me to just move down my branches here. So number 14, what is the current through the branch with all of the 5 ohm resistors? So I'm going to move the crosshairs over that, and I'm going to end up with 1.6 amps. 1.6 the whole way across that branch. And then finally, what is the current through the branch with the 15 ohm resistors? 0.80 amps. All right. So the last question asks, are the resistors arranged in series, in parallel, or in both formations? Now I'm going to explain this a little